Exercise number 7. Here they said the slope of the terminal ray is minus 3.732. Okay. So this means that this is, sorry, I have to just choose the pen. Yes. This means that the tangent of theta is this. Okay, because it means the point. I mean, when you have a line, okay, this angle from this to this, theta, its tangent is exactly the slope of the line. So this is the tangent between x and y. So this angle, its tangent is this number. Okay, so here we have tangent of theta equal to minus 3.7. Okay, and we know that tangent is also what? Is sinus theta over cosinus theta. And we know that sin square of theta plus cos square of theta equal to 1. This is a very important formula. So, and if we come back to this means that the sinus of theta is equal to tangent theta times cosinus theta. Okay. Okay. Times cosinus theta. And what is tangent is this. So it's minus 3 minus 3.732 times cosinus theta. So sinus, we can replace it with this here. So which means that minus 3.732 cosinus theta all squared plus cosinus squared is 1. So we will name cos theta x. That means that 3.732 squared x squared plus x squared is equal to 1. That means that x squared, if we factorize by x squared, is this squared plus 1 equal to 1. So x squared is 1 over all this. So it's 3.732 squared plus 1. Okay, but here we see that the cosinus is positive, so we will take only the root square of this. So x is root square of all this. Okay, so here if you do the calculation, we'll have 1 over, between parentheses, 3.732 squared plus 1, not here, plus 1. So it's this answer. And then we do cosinus minus 1 of the answer. So the the angle is 86.50, and they want to stop to the nearest around the three decimal places. Three decimal places. Oh, sorry, we have to do the root square of this. So if we do, yes, the root square of answer. So it is this. And they want just the three decimals. So it's 2, 5, and 8 only. Okay? But if we stop here, we have to make the 8, 9. That means that x equal to what? To this. This is the cosinus of theta. That what they want, because if theta was here, the cosinus will be negative. So we will take the minus of the root square. But here it's clear that it is positive. So we take only one value, the positive one. Okay. Here we have cosinus and sinus, and they want tangent. So tangent theta is simply the quotient of both. So it's sinus theta over cosinus theta, which means that it's minus. No, the sinus is the second coordinate, so it's this over this. That's it. So it's over minus 0.087. So the tangent is this. What they want here, they want maybe to stop at the nearest something. So we will check what they want. Rounded the three decimals. So another time 3 decimals, which we will stop at 8. It's minus 11.448. Okay, here 9. What fractional part of one semicircle does the labeled angle represent? Express your answer as fraction in simplest terms, then express the labeled angle in radian measure. So first, here what we have, all this angle is 310. So the portion part of one semicircle is 180 degrees. So this is the value of what we need to calculate the fraction about it. So it will be in the denominator, and the denominator it will be this. Okay, so it is clearly 31 over 80, which we cannot simplify. Now they want to transform this angle to radian, to convert it to radians. So we know that the value that we want, we have to multiply the value in degrees by pi over this. Okay, every time. If it is the the inverse, we have to, if we want to convert to degrees from radian, then we will do the inverse. It's this. Okay, so now it is what? It is 31 over 80 pi, and that's it. What is the other exercise? So this is the same exercise as the 9, so I think you can do it. This is also the same, you can do it. This is also the same. So 13, convert the following in radian, express your answer in simplest form. So we know that we have just to multiply by pi over 180. So we will do the calculation by calculator. Okay, have to then, yes. So this is the value, 47, etc. So it's 47 over 12 pi. Nice. Oh, same. You can do it. Now you can do it. You just have to multiply by the inverse. So it's pi over 3. So it's 60. This you can do it. You can do it. You can do it. Now you can do everything. Convert rounding. Okay, this, so my x is 2.5 times 100 divided by pi. So this is 36 plus, no, plus the half of, so it's this, so it's 415 over pi. So we have to calculate it, because pi is a number in degrees. So whoop, 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 whoop. So is this. So rounding to nearest tenth. So it's 0.2. Okay. Here, for example, 80, it is 11 pi over 12. Just by logic, we have to eliminate the pi, so the pi will be under, and here we will have this. So it is can we just calculate this? Oh, nice. I was sure that it will be a whole number. So it's this. Nice. Draw 11 pi over 6. Convert pi. Pi to convert it is this. So it's 180. 21. 21. Draw my. So here the idea is to transform this to a pair number, like because a pair like 2 pi, 4 pi, 6 pi, 8 pi, all this is one tower, this is two towers, 3, 4 towers. Okay, so if we have towers, we can eliminate them because we come back to the same point on the circle, on the unit circle. So how can we convert this to a number of towers, which means a multiple of 2 pi plus something? So we will search the nearest multiple of 6 to 11. It's 12. 12 pi minus pi, which is exactly 11 pi over 6. And then it's 12 pi over 6 minus pi over 6. This gives us 2 pi, which is 1 tower. So this is the same on the circle as this. And minus pi is when you have pi, when you have 1/2 here. We know that we will have here pi over 6, as we learned yesterday. So the minus, it means that from this is plus pi, and from this to this is minus pi. So here is our point. It's 11 pi over 6. And you can count it. 1, if we see this, look. If we take it, 1, 2, well, anyway. Here we have pi over 3. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's correct. You can also say that we can minus how to. Yes, it's 2 pi. No, it's exactly this. I wanted to give you another trick, but just keep it like this. So it is this point, and we draw it. Okay. Here, draw pi. We know that pi over 4. How we draw it? We do here the half. Exactly. Yes.
صل على محمد.
The half. But it have to be exactly the, yes. And then do this. So this is pi over 4. Okay. Then find the exact value of sinus. Okay. The exact is find. Why did you say find? Okay, anyway. So this is the sinus. Okay. And this is my pi over 4. Sinus of pi over 4 is this distance, x, over the radius, which is 1. Okay, so this is exactly, and we have also, we know that cosinus is also equal to h. Is x over 1. So they are equal. So sinus pi over 4 square plus cosinus pi, it's 1. So because they are same, 2 sinus square is equal to 1. So sinus is equal to root square of 1 over 2, which is this. But you can, I think, do it directly because they already gave you the values on the circle. So you can say directly in other color that sinus of pi over 4 is root square 2 over 2. Okay. 23 is, where is 23? Yes, it's here. Wow. Okay, 23. Draw pi. Pi is here. Then find the exact value of sinus. Sinus is what? Is 0. Here. 24. 24. Draw 5. So we know that pi over 3 is here. When you cut this distance over by 2 or on 2, you divide it by 2. So here is your pi over 3. So if you do the diametral stuff, it will be pi plus p over 3. They want 5. Okay. So we will do the stuff we did before. 5 pi over 3 is 6 pi minus pi over 3 over 3, which means 2 pi minus pi, and minus is here because this is plus and this is minus. So our punch is here, 5 pi over 3. Okay. You can do it by another technique, because we know that here we have 2 pi over 3. So we do it with the diagonal. It will be, this point will be what? 2 pi over 3 plus pi, which is 5 pi over 3. So both techniques are available. Okay, then find the cosinus. So the cosinus, as we see, is the same as the cosinus of pi over 3, which is 1/2. So cosinus 5 pi over 3 is cosinus of, we can say also is cosinus of minus pi over 3, which is cosinus of pi over 3, which is 1/2. Why? Because in a circle, x and minus x has the same cosinus. That's why we removed the minus here. Okay. So maybe we can move this here to make this little bit above. Okay, to let the place to 25. Find the exact value of cosinus. Wow, cosinus p over 2 is 0, because pi over 2 is here, so its cosinus is 0. Find the exact value of 4 pi over 3. So 4 pi over 3 is what? Is 6 pi over 3 minus 2 pi over 3. So it's 2 pi minus this. And in the unit circle, pi over 3 is here from 1/2. 2 pi over 3 is here. Minus is minus 2 pi over 3. And it has the same cosinus as this one, which is another time more minus 1/2. So cosinus of this is cosinus of minus 2 pi 3, which is cosinus of 2 pi over 3, which is minus 1/2. Sinus, it's known, it's this. 3 pi over 3. So 3 pi over 2 is what? Is 4 pi over 2 minus pi over 2. So sinus of 3 pi, which is 2 pi, which is 1 tower, so it doesn't count. So it's sinus of minus pi over 2, which is minus sinus pi over 2, because sinus minus x is minus sinus x. Okay, so, and we know that sinus pi over 2 is 1, so sinus 3 pi over 2 is minus 1. 11 pi over 6 is 12 pi minus pi over 6 is 2 pi, that you can eliminate. So sinus of 11 pi over 6 is exactly sinus of minus pi over 6, which is minus sinus pi over 6. And what is this? Sinus of pi minus 6 is 1/2, so it's minus 1/2. Okay. This one, cosinus of 3 pi. So 3 pi over 2 is what? Is 4 pi minus pi over 2 over 2. So it's 2 pi minus pi over 2. Cosinus of all this, so it's cosinus only of, because we can eliminate the 1 tower, come back to the same point. And cosinus minus x is cosinus x, so it is 0. Last one, cosinus 2 pi 3. We know that pi over 3 is here from 1/2, and 2 pi over 3 is here, so it's the opposite of it. So cosinus of 2 pi over 3 is minus 1/2. Okay, so we stop here, and if you have any question about all this, just tell me, and I will will have a great pleasure to answer you anytime.